Telematics broadcast this afternoon. My name is Eleanor Splinter, and today it's so nice to be back with you, and we are going to be doing sketching calculus graphs today. So welcome. I hope that you're all excited, just as excited as I am to be teaching you this afternoon. And I know that all the grade 12s, you've just finished your trigonometry. We did double angles, we did compound angles, and now your teachers should all be busy with calculus. So that is differential calculus, where we find the derivatives. And on this telematic session today, I am going to be doing the graphs of cubic functions. So in this afternoon session, you must take out your telematics books, and I will be sketching one graph with you. I'm going to teach you how to sketch the graph, then you are going to sketch one graph with me. And after that, I'm going to give you a graph, then we are going to find the graph's equation. So this is what we want to do this afternoon. We want to look at a tangent to the graph. We want to look at derivatives. We want to look at turning points and points of inflection. So that is quite a mouthful. Now remember, grade 12s, that calculus is about 35 to 40 marks in your exam paper 1. This paper 1 is 150 marks, and can you imagine that the calculus section is 35 marks to 40 marks. So you can just about see how important this section is in paper 1. And I know, having taught for so long, that learners do not like the graphs in paper 1. But unfortunately, in calculus, there's a graph again, and we need to do it well. It is not so difficult. I promise you, you are going to get the hang of it after this afternoon session. So without wasting any more time, let's now take your calculus book. So this is your calculus book that you all received at school, and I am going to be doing question number 1A. If you look carefully, this is on page number 3. So get your calculus books out, and everyone, we are going to do question 1A on page 3. Just while you're all getting your books ready, your pens, your pencils, get an eraser as well. You're going to need your calculators. I'd like to welcome everyone that's watching, and I hope that you are going to enjoy this afternoon session. Remember that if you have any questions, you can WhatsApp us at 062 476 8700. So you know where to WhatsApp us, and I will do my best to answer your questions. Are you all ready? It is example number 1A on page number 3. Okay, here we go. So this afternoon, we're going to be doing calculus graphs, like I said. You can see my heading is calculus graphs, so I'd love for you to write your heading as calculus graphs, and example number 1A on page number 3. Okay. So you were given this f of x function, which is 2x cubed minus x squared minus 4x plus 3. You are given this function. Now let me write this function down for you. It's f of x is equal to 2x cubed minus x squared minus 4x plus 3. You are given this function. Right. The very first question that we see there is, they say, show that x minus 1 is a factor of f of x. Now, okay, let me explain factor to you quickly. When we were in grade 6 and grade 5, we would always remember 2 being a factor of 4. Why is 2 a factor of 4? Because it divides into 4, leaving no remainder. 5 is a factor of 10 because it divides into 10. How many times? 2 times. You have no remainder. Now again, in this question here, they say that I must show that x minus 1 is a factor of f of x. So grade 12, what you do for number 1 is the following. We have to show that x minus 1 is a factor. The first thing that you do, you put that equal to 0, and you get x alone. What is x? X is 1. Now you're going to substitute the 1 into the place of x, and you're going to see whether you get 0. Do you understand? 2 is a factor of 4 because your remainder is 0. Now when you are substituting this 1 into the place of x, you are seeing whether you have a remainder or not. If your remainder is 0, it means that x minus 1 is a factor. So come, everyone that is watching this afternoon, Sikufle as well, substitute the 1 into the place of x and see what you get. If I'm substituting 1 into the place of x, you can see that I'm replacing the x with 1. So replace your x with 1 there as well. Everyone, you are substituting with me 4 multiplied by 1 plus 3. Remember, you are using this function and you are seeing whether x minus 1 is a factor. I'm so sorry. You are going to work this out. I'm so sorry, everyone. That's 2 minus 1 minus 4 plus 3. What do you see? F of 1 is equal to 0. That is fantastic, Zukile. You immediately knew that x minus 1 is a factor. Let's look at the logic. Why is it a factor? Because the remainder is 0. So x minus 1 is a factor the minute you substituted 1 into the place of x. Then you want to go see whether there is a remainder. The remainder is 0. So x minus 1 is a factor. We have just answered number 1. That is fantastic, Tokozani. You said x minus 1 is a factor because when substituting 1 into the given function, you get 0. Tokozani, I don't think that I could have explained that any better. You explained yourself beautifully. Let's go to number 2. Number 2 says, hence factorize f of x completely. Hence means use number 1 in order to do number 2. If I'm going to factorize this completely, I am going to do the following. When you factorize f of x completely, you are finding the x-intercepts. So you have 2x cubed minus x squared minus 4x plus 3 is equal to 0. Why are you putting it equal to 0? Because you are finding the x-intercepts. Are you okay with that? Now you have a factor already. Now, grade 12, if you can listen to me very carefully, I do not want to confuse you this afternoon. There are so many different methods that you can find your x-intercepts. You can use synthetic division. You can use the method that I'm going to show you this afternoon. Some students with those silver calculators, you type it onto your calculator, you get your x-intercepts. My advice to you this afternoon, use the method that you are most comfortable with. Don't let anyone confuse you. Use the method that you are comfortable with. Now, this is my method. See if you understand it. I want to factorize this cubic function, and I have my first factor, which is x minus 1. Remember, x minus 1 was a factor. We substituted it into number 1. We saw that it is a factor. If it's a factor, that goes into your first bracket. Now you want to get your second bracket. Okay, how do you get this? If you want to make notes, if you're struggling with this, watch closely. The method that I use is very, very simple. I simply say x multiplied by what gives me 2x cubed. Let me ask that question again. X multiplied by what gives me 2x cubed. What is that? 2x squared. So you put your 2x squared down there. Are you happy? Then you're going to say negative 1. Remember, that's step 1. Step 2, negative 1 multiplied by what gives you plus 3. What is that? Negative 1 multiplied by negative 3 gives you plus 3. Everybody understands that so far. Now the middle term is what we're all battling with. Now see if you understand this. I merely multiply these two together and that gives me negative 2x squared. So negative 2x squared, how do you move and you compare it to that x squared? How do you move to negative 1x squared? Remember, you must either plus or subtract something to get to negative 1. So negative 2, how do you get to negative 1? You must say plus x. Excellent. This is plus x here. Now listen, grade 12, this is negative 2x squared plus x squared will give you negative 1x squared. Remember, you always compare it to the x squared term. So I have negative 2x squared plus 1x squared gives you negative gives you negative 1x squared. So I put a plus 1 there. So this is plus 1 that I need. I hope that you understood this method. I'm going to explain it one more time. Your first step is to put your factor that you found into your first bracket. You all understand that. X minus 1 is a factor. Then you say x multiplied by what gives me 2x cubed. X multiplied by 2x squared gives me 2x cubed. So everybody understands the 2x squared. Then you take your last term, negative 1 times negative 3 gives you plus 3. Now look at the middle term quickly. It's not so difficult. Negative 2x squared, multiply these two together, that gives you negative 2x squared, but you need negative 1x squared. So how do you move from negative 2 to negative 1? You plus 1. Okay, now I have my brackets and I'm going to factorize. That gives you x minus 1. Grade 12s, can you see that this is a trinomial? And we're going to factorize it 2x and x. Factors of 3 is 3 and 1. You need a plus x, so I'm going to put my minus there and I'm going to put my plus there. So what are your x-intercepts? Your x-intercepts will be x is equal to 1 or x is equal to, take the 3 across, divide by the 2, negative 3 over 2. Somebody says, ma'am, I've never done it like that, but it is great. I'm glad that you understand it. I hope you took down notes. Remember, I don't want to confuse you. Stick to a method that you understand. And when we get to our next sum, we're going to try it again, okay? Did you all get your x-intercepts to be x is 1, x is negative 3 over 2, but that is also x minus 1, so that is the same x-intercept. Now make a big NB here because I'm going to teach you something about the following. Can you see that your x-intercepts, there is an x-intercepts that's the same. These two are the same. So I'm going to say something about that turning point later. Okay, so we can tick number 2. We factorized f of x completely. Okay. Let's go to our next question, and the next question says that we have to determine the coordinates of the turning points of f of x. So we are following our questions like they gave it to us in our telematics books. Determine the coordinates of the turning points. Now make a note for me, grade 12. This is how you find your turning point. So this is number 3. Are you all writing number 3? And this is how you find your turning points. Right, make these notes for me. Number 1, first determine the derivative. That's step number 1. Okay, so come do this with me. Your f of x is equal to 2x cubed minus x squared minus 4x plus 3. So step number 1, if you have the turning points already, you can SMS it, WhatsApp it through to us, then I can check whether you are right. The students who do not know how to get the turning points, everyone watching this afternoon, you are making notes. So the first step that we did, we found a factor, that was for the x-intercepts, then we factorized it, and now we're going to find the turning points. If you want to find the turning points, you can send it through to me if you know how, but if you don't know how, these are your steps. Step number 1, find your derivative. Okay, now everybody should know how to find derivatives. How do we find the derivative? You take your exponent, you times by the number in front of x cubed. 3 times 2 is 6, and you take away 1 from the exponent. What is 3 minus 1? It is 2. Then you do the same here. The derivative of this, what is the number in front here? If you don't see a number, everybody knows that number is 1. So it's 2 times negative 1, which is negative 2. And you take away 1 from the exponent. What is 2 minus 1? It's 1. The derivative of negative 4x, watch closely. There's a 1 here. 1 times negative 4 is negative 4. If I take away 1 from the exponent, 1 minus 1 is 0. Anything to the power of 0 is 1. And the derivative of a constant is 0. There is no x there, so it is regarded as a constant, and the derivative of a constant is 0. So that is step number 1. You found your derivative. Matrix, what are we busy doing? We're finding the turning points of the cubic graph. Just like in a parabola. Do you remember the parabola? We found our x-intercepts, we find our y-intercepts, and then the turning point. Now this is the same in the cubic graph. You find your turning points by finding the derivative first. Number 2, you make your derivative equal to 0. You are all writing these steps down. Make your derivative equal to 0. Now this is my derivative, so you're going to say 6x squared minus 2x minus 4 is equal to 0. When you make your derivative equal to 0, can you see that you can determine x? I'm going to divide through by 2 because 2 can go into 6 3 times, 2 can go into 2 once, and 2 can go into 4 twice. Then I'm going to factorize this. Everybody can factorize a trinomial. This is 3x and x. I'm going to use 2 and 1, putting my 2 here and my 1 there. Are you happy, everyone? That's 3x squared. No, the 2 goes here and the 1 goes there. Right, so that's 3x squared. I need a negative, so there's your negative and there's your positive. I need a negative 1. Are you happy with that? So what is your x coordinates of your turning points equal to? Take the 2 over, negative 2 over 3, or x is equal to 1. Now, Annalise, you already said that, man, the one turning point is equal to 1, and that is 0. Beautiful. I just wanted to look at this question here. What happened to the negative 4x in question number 2? Remember quickly, let me go look at question number 2. Oh yes, if you multiply this out, someone said, ma'am, what's happening to the negative 4x? Don't worry, if you multiply out these 3 brackets, remember that you're going to get that again. If I multiply this out, this times that, that times that, that times that, and I multiply like normal, then I'm going to get that again. Don't worry, we're going to do another example number 2 where I show you to factorize. Right, this is now the turning points. Everybody, you remember that I said that you must find the derivative. 3 times 2 is 6, take away 1 from the exponent. 2 times negative 1 is negative 2, take away 1 from the exponent, and the derivative of negative 4x is negative 4. The derivative of a constant is 0. You take your derivative, you make it equal to 0, and you solve for x. We've solved for x, we got negative 2 over 3, and we've got the 1. Now what is your last step? Remember that a turning point doesn't just have an x coordinate, it also has a y coordinate. So how are you going to find the y coordinate of your turning point? You take these x's that you have and you substitute it back into the original equation. Right, so everyone, you are busy doing that. So to find, everybody write this down, to find the y coordinates of your turning point, substitute x equal to negative 2 over 3 and x equal to 1 into your original equation. Or we can say into f of x. Right, I'm going to wait for you quickly to write that down, just see if everybody is okay. And then we have to find the y coordinate, substitute this into f of x. I want you all to sit with your calculators to take this point, substitute it into f of x, substitute the 1 into the place of f of x, and you can tell me what you get. If I substitute now, then I get, remember we are finding the y coordinates of the turning point. So you take your f of x, which is y, and we substitute it into the original equation. So it's 2, I'm substituting negative 2 over 3 cubed minus negative 2 over 3 squared minus 4 times negative 2 over 3 plus 3. If you substitute this, if you put this into your calculator, we're not going to spend time doing that. You can do that. You get a value of 125 over 27, or if you put it in decimal form, 4,63. So your one turning point matrix is negative 2 over 3 and 4,63. Your other turning point, you are going to substitute 1 into the place of x. And we don't even have to go and put this on our calculator because we did it already and we saw that it is 0. So your other turning point is 1 and 0. And there we have those questions there. And then the next question says that we now have to draw a neat sketch graph of f of x indicating the turning points as well as the x-intercepts. I want to ask you something. Is there something that you noticed? Was there something that you could see? Do you know what? When I found my x-intercepts, I saw that my one x-intercept was equal to 1. I don't know if you remember that our one x-intercept was equal to 1. And it was repeated. Look at that. Your x-intercepts there were repeated. You had the same x-intercept. Now, if one of your x-intercepts are repeated, matrix, you find that it is also a turning point. Can you believe that? That when you have an x-intercept that's being repeated, it is also your turning point. This only happens if your x-intercepts are repeated. I am now ready to draw the graph with you. So the graph was the following. Let's just summarize. Before you can draw a graph, you need, here's your f of x. Let's write it again. It was 2x cubed minus x squared minus 4x plus 3. Before you can draw the graph, let's write our steps down. I know my y-intercept is 3. That's easy. Hey, matrix, your y-intercept is always the value of your constant. Are you happy with that? Then your next steps were your x-intercepts, and we found our x-intercepts to be x equal to, do you remember? X was equal to 1, or x was equal to negative 3 over 2. X is 1 or x is negative 3 over 2. And your last steps was your turning points. And I hope that each and every one of you wrote down these steps. These are the steps to find your turning points. To find your turning points, we found the derivative. We made the derivative equal to 0 and we solved for x. We took these x's and we substituted it back into the original equation. And there you have your turning points. Your turning points were 1 and 0, and your other turning point was negative 2 over 3 and 4,63. And grade 12, with this information, we are now ready to go and draw our graph. That's your y-axis, this is your x-axis, and this is your origin. I'm waiting for all of you to draw your y-axis, your x-axis, and your origin. And I am going to sketch this with you. There's my y, there's my x. Let's sketch together. The y-intercept was equal to 3, and you put your 3 down there. Right, your x-intercepts were 1. Remember, these graphs are not drawn according to scale. And your other x-intercept was negative 3 over 2. Now, negative 3 over 2 is negative 1 and a half. So you more or less know it's slightly this way from the origin. And there is negative 3 over 2. And then you're going to plot your turning points. Let's plot the turning points, everyone. The one turning point we already know is 1 and 0 because it is also an x-intercept that has been repeated. And now you have negative 2 over 3, which is more or less here. And there you have 4,63. So this is negative 2 over 3 and 4,63. Your graph will cut the x-axis there. It turns there, it cuts the y-axis, it turns at the x-intercept, and it goes up like that. And this is the graph of f of x. While I look at the questions, I'm waiting for you just to sketch your graph to see if you understand. And when trying to find, you easily subtract the coefficients and the constants. That's absolutely correct. You could go and see that this is a factor here. 2 plus 3 minus 5 is 0 if you substituted the 1. Are you all okay with this graph that I have just sketched for you? Did you all understand how we sketched this graph? Now, grade 12, let's see if I've now done that graph with you. Can we immediately go to question number 2 and you now see if you can work with me? I've got this graph here. And it's question number 1B in your telematics books, and that is on page number 3. And you all know that you can now try and sketch this graph with me. So it says, like in your books, I am not going to do the point of inflection for question number 1. We're going to do it here. F of x is x cubed plus x squared minus 5x plus 3. We want to sketch the graph of f of x. So you haven't been given any steps. Right? So write down this is question number 1B in your books, and you have f of x is equal to, I write the function down, x cubed plus x squared minus 5x plus 3. Right, we want to sketch this graph now. Now remember, in question number 1, we led you step by step to sketch the graph, but this question just says that you must sketch the graph yourself. So in your mind, you need to have your steps. I need to have my steps to sketch this graph. So let's see, what was step number 1? Step number 1, we know, was to find the y-intercept, and the y-intercept is equal to 3. You can put it in coordinate form, 0 and 3. So that was step number 1, and you happy with that? Everybody, you understood that. Now we're going to find our x-intercepts. Do this slowly with me. In order to find your x-intercepts, you make y equal to 0. So that's step 1. Take your function, your f of x, it's x cubed plus x squared minus 5x plus 3 is equal to 0. Remember, you want to find your x-intercepts. So where does this graph cut the x-axis? Obviously, on the x-axis, y is 0. Now you need to find your first bracket. How did we find the first bracket? You need to find a factor. Now, how do you find a factor? You substitute values into the place of x and see if you get 0. Now, usually those values that you substitute will be factors of 1 and 3. So it can just be 1 or plus 1 or minus 1 or plus 3 or minus 3. You must go and check. Now, one of the students sent Zukile again. You sending through again. X minus 1 is again a factor. How did you get that? Substitute 1 into the place of x, 1 into the place of x, 1 into the place of x, and what do you see? 1 plus 1 is 2, plus the 3 is 5, 5 minus 5 is 0. Yes, so you already know x minus 1 is a factor. So x minus 1 goes into your first bracket. Now remember, this is a new method, or a method that I've shown you this afternoon. It might be different from what your teacher showed you. Like I said, do the way that you understand best. So some people go into synthetic division, or you can follow this method. Watch again how we get the second bracket. Okay, x multiplied by what gives you x cubed. This must be x squared. And you check quickly, x times x squared is x cubed. Are you happy there at Sikufle? Then you say negative 1 times what? Give you plus 3, negative 3. Can everybody see? So I just check with my hands. X times x squared is x cubed. Negative 1 times negative 3 is plus 3. Now we just do the middle term. How do we get the middle term? We multiply these two together. That is negative x squared. But how many x squareds do you have there? 1. So you have negative 1, but you need to go to plus 1. So negative 1, what do you need to add? Think quickly. Think, everyone. You have to add 2. Remember, negative 1 plus 2 gives you 1. And that is what you want there. Negative 1 plus 2 gives you 1. So that gives me plus 2x. Negative 1 plus 2x. Right, so it's negative 1x plus 2x is going to give you 1x. Are you happy, everyone? So there is your factor. Can we check again? X times x squared gives me x cubed. Negative 1 times negative 3 is plus 3. I multiplied that together. Negative 1. But there's a plus 1. So I need to get to plus 1. So if I have negative 1 plus 2, I'm going to get that 1x. I factorized now. Now we have this bracket here. And can we factorize? X multiplied by x, give me that x squared. Remember that you need to use -3 to get to +2, so that's quite easy, everyone. It's +3 minus 1. Everybody, are you happy? Your x-intercepts are 1 or x equal to -3. Now, what do you notice again? I specifically took this example again because it's so similar to question number 1, and I want you to understand it before we go to something more difficult. What do you see? These x-intercepts are again being repeated. So what do you know? This is also going to be a turning point. Right, so we're sketching this graph. We found our y-intercept, which is 0 and 3, and our x-intercepts, very simple. We found it to be 1 and -3. What is your last step? Good day, Exodus. I hope that you're enjoying the lesson as much as I am enjoying teaching it to you. We are now going to find our turning point, Exodus, because this is our last step in sketching a cubic graph. So the turning point is our third step. We take our function f of x, which is equal to x cubed plus x squared minus 5x plus 3. We said that we found the turning points by first finding the derivative. Okay, everybody, can we work out the derivative? 3 times 1 is 3. Take away 1 from your exponent. You understand that, eh? 3 minus 1 is 2. Then 2 multiplied by 1 is 2. And take away 1 from your exponent, gives you 2 there. The derivative, 2 minus 1 is 1. And the derivative of -5x is -5. Once you found your derivative, you take your derivative and you make it equal to 0. You factorize it. I hope you're all taking good notes. 3x and x, that's good. Factors of 5 is 5 and 1, but you need 2. So I'm going to put my 5 here, I'm going to put my 1 here, my minus there, and my plus there. Are you happy? 3x squared minus 3 plus 5 is plus 2, and your x coordinates of your turning points will be -5/3. Oh my word! It must be 1. Why must I have a turning point at 1? Because my x-intercepts were being repeated at x equal to 1. Now, these are the x-coordinates of your turning points. How do you find the y-coordinates of your turning points? You know, somebody already sent it through, and I'm so proud of you. Remember, you are going to take the 1 and substitute it into your original equation, but we know already that we get 0. We don't have to do that again. And then you take the -5,3, -5/3, and you substitute it into the place of x. And I'm just substituting here, -5/3 squared, -5 times -5/3. It's a lot of work, grade 12s, to sketch this graph. And if you do that, you're going to get 9,48. Just like someone sent it through to me on WhatsApp. That is so amazing. Just check quickly. The person who sent through -1,67 and the 9,48, your 9,48 is beautiful because that is what it's supposed to be. I just don't know where you get the -1,67 from. Just check quickly. Why are you getting that? So your turning points will be 1 and 0, and your other turning point is -5/3 and 9, -5/3 and 9,48. Now with this information, grade 12, we are ready to sketch our graph. I'm quite excited to see what my graph is going to look like, and I hope that your graph is also looking like mine. Draw your y-axis, your x-axis, and your origin. Because I want to do something else with you also this afternoon, let's just do this roughly. That's my y-axis, my x-axis, and my origin. Okay, let's go and substitute, plot everything that we found. Our y-intercept was 0 and 3. Right, everybody, plot your 0 and 3. Thank you, Natalie, for that beautiful comment. Calculus isn't so difficult, and it's 35 marks in the exam, so we really, really want to get those marks. Hey, it gets a bit difficult in our next lesson when we work with boxes, but let's first get the graph right. 0 and 3, got it. Did you plot it, everyone? Okay, let's plot our x-intercepts. The x-intercepts that I found was the 1 and the -3. Take your graph, plot 1 and plot the -3. Right. Can you see, grade 12s? I'm plotting my graph just as I found my steps. Y-intercept, x-intercepts. What's the only thing that is left for me to plot? My turning points. And the turning points were, of course, the one turning point must be 1 and 0 because this bracket was being repeated. Well, you always remember that. If a bracket at your x-intercepts are repeated, it automatically becomes a turning point. So there's my one turning point. You know what I do? If I do a turning point, I circle it because I know that it has to turn there. And the other turning point is -5/3, which is -1 2/3, which is somewhere here, and 9,48. All right, it can be anywhere. It doesn't have to be according to scale. I'm just going to drop this page so that you can see -5,3 and 9,48. And grade 12, I wish that I could see what your graphs look like. Unfortunately, I can't because, I can't send me the picture, but see if it looks like mine. I know that it has to cut the y-axis here, the x-axis here. I know that it has to turn there and it has to turn up. And you go up, turn, cut the y-axis, and there is the graph of f of x again. I hope that your graph looked like mine and that you now have the steps. Let's just quickly revise the steps. Nobody looking out of the window. Don't talk to your friends. Don't chat. Just quickly, what are the steps for finding and sketching a calculus graph? Number 1, your y-intercept. Number 2, your x-intercepts. Number 3, your turning points. How did we find the turning points? Derivative equal to naught. Find the x's, sub it back into the original equation. Are you happy with what I've done so far? Okay, what I want to do now is, do you think that I could do question 2, 3, and 4 as it is in your telematics books? The second question there, the graph increases at 1. I can already see. Look, Exodus, you're saying, wow, you understand. Let's just quickly see. Determine the point of inflection. Now, the point of inflection is found in the middle of your two turning points. Remember, the point of inflection means where the concavity of your graph changes. Now, we're not going to ask you to give us a definition of the point of inflection, but we're going to find you to work out the point of inflection. There are two ways to find the point of inflection. Do you know the way that most teachers explains it is by using the second derivative, or the way I explained it is just in the middle of your two turning points. So there's a turning point and there's your turning point, and you just find the middle. So if I get number 2, the point of inflection, everyone work out the point of inflection quickly. You all know that we get it by second derivative, or we're going to find the middle of the two turning points. Work it out quickly, then I quickly look at some questions. It's almost the same, but I did not substitute it into the original equation. Okay, Exodus, I can see. Remember, it goes into the original equation, not into the derivative. Never, never. Okay, what is the point of inflection? So your midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Make a note for me. Point of inflection, it's in the middle of the turning points. So the middle is just your midpoint. So you substitute -5/3 plus 1 divided by 2, and this would be 9,48 plus 0 divided by 2. Are you happy with that, everyone? Now, if you work this out, you are going to get -1/3, or you're going to get 4,74, and this is your point of inflection. Now, for the students who work out the turning point using the second derivative, you will get exactly the same answer. It just takes a bit longer, but you get the same answer. Second derivative, so your first derivative, everybody knew, was 3x squared plus 2x minus 5. Your second derivative, 2 times 3 is 6. Take away 1 from the exponent. The derivative of 2x is 2. You take your second derivative and you make it equal to naught. Can everybody see that x is equal to negative a third? Just like I got there. And then, how do you get the y? Always remember, Exodus, this is again for you. You substitute it back into your original equation. Remember, never into the derivatives equation. Are you happy? And if you work that out, you will get that answer that I got of 4,74. So point of inflection is in the middle of your two turning points. It's at negative a third and 4,74. Point of inflection, just get the middle of the two turning points, or find the first derivative. Then you get your second derivative. Make your second derivative naught. Take that value that you got and sub it into your original equation. Remember quickly, grade 12s, if ever you are looking for a y coordinate, whether it's the y of the point of inflection, whether it's the y coordinate of the turning point, always take the x's that you found and substitute it back where? Into the original equation. Okay, everybody, are you okay with point of inflection? Second derivative equal to naught. Get the x's back into the original equation. Or the simple and easy way, point of inflection is always the middle of your two turning points. So just work out your midpoint. Okay. The next question that I'm going to do, and I've just heard that we have 5 minutes left, and 5 minutes would be enough for me to answer this question, where they ask, for which values of x is f of x increasing? For which value of x is f of x increasing? Now look quickly, the graph increases. Can you watch me closely? This is increasing. Remember, you started here, so it increases there, and then the graph decreases. I'm going to take a different color so that you can see it decreases in between your two turning points, and then in red again it increases. You all understand the increases and the decreases. A graph increases if your gradient is positive. It decreases if your gradient is negative, and it increases again if your gradient is positive. Now that's easy to see where it increases, but how do I write it? And they ask you for which values of x, so you focus on the x values. Do you understand? I didn't say for which values of y. They don't ask the question like that. For which values of x will the function increase? Everybody can say it increases, decreases, increases. So it increases for all x's smaller than negative 5/3. Can you see? If I put my Coke here, all my x's are smaller than negative 5/3. So this answer here would be all x's smaller than negative 5/3. But it also increases again when x is greater than 1. When x is greater than 1. That is the answer for increasing function. So what would it be if I asked for which values of x will it decrease? It will decrease between minus 5/3 and 1. Can everybody see that? It decreases between minus 5/3 and 1. Okay, let's just see if I can quickly see. Okay, Exodus, you say, oh, that is how, and I'm very happy, thank you. And then, and Elisa, I'm glad that you're enjoying telematics. I think in the last 2 minutes that I have, it's no use I'm going to start with the tangent, but this question always pops up in calculus, so if you can give me 2 minutes and just watch determine the equation of the tangent, I'm just going to say to find the equation of a tangent, remember a tangent is a straight line. So y equal to mx plus c. And then you know that you must find the gradient and you must find c. One hint, to find the gradient is equal to derivative. If anybody ever asks me, Eleanor, what does derivative mean? You know, derivative, we work with derivatives, but what does derivative mean? Derivative means finding the gradient of a curve at a specific point. So derivative means finding the gradient. So if your teacher asks you again to find the equation of a tangent, tell them a tangent is a straight line. To find the gradient, tell your teacher you're going to find the derivative. at a specific point. So what point are you going to find the derivative at? At x equal to 2. And then you're going to find c. But now I'm almost over time, so you're going to find c yourself. We know how we find c. We just substitute something in the place of y and something in the place of x. So this afternoon we summarize gradient is equal to derivative. Derivative means finding the gradient. So if we end off, will we all be able to sketch a calculus graph now, a cubic graph? Would you be able to know which steps to follow? Will you know when a graph is increasing or decreasing? And would you know what to do when asked to find the point of inflection? Remember, that was the lesson this afternoon, and I hope that you understood the lesson and that you enjoyed it as much as I did. All right, and then just before I go, do you know that after 5 o'clock, Stellenbosch University, if you stay in your centrums, they are going to give you hints on studying, and they are going to give you tips on studying and how to go about preparing for your exam and preparing for your future. My advice to you, don't go home. Why don't you stay till after 5 and listen to all the hints that the university is going to give you? Remember, every little bit is going to help you in preparing for your future. Grade 12s, it was amazing being with you. Go and sketch those calculus graphs and enjoy it, and we see you next time. Bye-bye.